All right, make sure you have your scratch paper. Follow along for the Math on the Spot video.
Mulch, mulch, mulch. Oh, hi. How are you? Sorry about that. I was just taking care of my beautiful bamboo plants. Aren't they beautiful? So I was just doing some gardening just around the math classroom, and I thought, this is looking very good, by the way. But you know what's even looking better? This bamboo plant reminds me, in fact, of a great math riddle about bamboos. Let's take it out together and see if we can figure it out. And also, I want to figure out what you do with this, because I'm not exactly sure. But we'll save that for later. Okay, so let's have some fun thinking about the math. Well, the graph that's shown right here, in fact, it shows the growth of a bamboo plant. The height y in centimeters of a second bamboo plant is given by the equation y equals 30x, where x is the time in days. Our challenge is to see if we can describe how the graph showing the growth of this plant would compare to the graph showing the growth of the first plant. So it's interesting. Here we have these two bamboo plants that are growing. And the information that we're given for the first bamboo plant is a visual piece of information as the days go by, how the height of the bamboo plant changes. For the second bamboo plant, we're not given a picture, we're actually given an equation. And we want to see how we can make sense out of both those things. So first of all, just the facts, please. Well, the facts, first of all, remain that, hard to do with my gardening gloves, but this is a gardening question. So the first thing we know is that the graph showing the growth of the first bamboo plant is right here. The equation for the second bamboo plant is y equals 30x, where y represents the height in centimeters, just like it was here, and x represents the time in days, just like it was here. Okay, so let's think about this now. If we take a look at the bamboo plant, the first one, that's given by the graph, what we notice is, what about the growth of it? Well, notice that in one day, the plant will grow 50 centimeters. And that continues. Notice 50 centimeters in one day, and then another 50 centimeters in the second day, and so on. It kind of forms like a little L. Do you see those kind of like little upside-down Ls? You can see those upside-down L's actually right there live, and you can kind of see, you can really see those L's. And what that really tells us is that each day, each and every day, the height of the first bamboo plant increases by 50 centimeters. And we can see that because one day, 50 centimeters, another day, 50 centimeters, and so forth. So we can see it. It kind of determines the steepness of the line. Okay, now let's turn to the second plant. That one we don't have the graph for, we're just given an equation, but it turns out that is enough for us to think about. The equation, of course, was y equals 30x. So let's make up a table for various days and use this equation to figure out the corresponding heights. Because remember, x represents the time, and y is going to give us the height. So these are the x values, and these are going to be the corresponding y values. So let's try it and see what we can do. So if we try it, what we see is the following. Well, if one day we plug in 1 for x, and we see 30 times 1, that's going to be 30. That's going to be 30. So the height is 30. If we plug in 2, if there's 2 days, then x equals 2. If I put in 30 times 2, that's going to be 60. So that's 60. If I plug in 3, that's 30 times 3, which is 90. If I plug in x equals 4 for the time being 4 days, then y will equal 30 times 4, which is 120. 120. Hard to do with gardening gloves. This is why you don't see a lot of people doing math riddles wearing gardening gloves. Now we know why. But I'm a professional, I can do both. And then if we have 5 days, that means the time is 5. That means x equals 5. So the corresponding y, height, would equal 30 times 5. And 30 times 5 is 150. 150. Now, when you look at these numbers, what do you see as we go? 30, 60, 90, 120, 150. What we see now is something very different than we saw before. In the first bamboo plant, each day the height increased by 50 centimeters. Here, how is the height increasing? To get from 30 to 60, we add 30. To get from 60 to 90, we add 30. To get from 90 to 120, we add 30. And so what we see now is with the second plant, we see each day the height increases by 30 centimeters. And so what does that mean? It means that as the days go by, we're only going to go up to 30, and then we're going to go up to 30 again, and 30 again, and 30 again. And so what does that mean? It means that the first bamboo plant is actually has a height that's increasing at a larger rate than the second bamboo plant, which means that the second plant would have a line that's actually less steep than the first, because when one day is up, instead of going to 50, it's only going to go to 30. Then the next day, it's only going to go up to 60, and so forth. So without doing any more work, we can actually answer the question. We could compare how the graph would look, because the graph would be less steep. And we can see that because we see that here we have 30, which is smaller than 50. And that's it. But just for fun, the question's over, we did it, we can go home, hooray. But just for you and for me, because you're curious, you might be wondering, what if we plot those points? Let's actually see that line. So I plotted those points already in blue, and I'm going to show them to you right now. Bling, ding, 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 dun, 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 and now you can see, this in fact is the graph of these blue values, and you can see that our conjecture is actually visibly clear. Namely, this blue line, which is the second bamboo plant, actually has a graph that is less steep than the first one. Now we saw that numerically because the first one increases by a height of 50 centimeters each day, while this one's only 30 centimeters each day, but now visually you can actually see that. That's the power of visualization. It allows you to actually see a pattern. And this is all about finding patterns, using equations, and looking at graphs. Well, looking at graphs, finding a pattern, finding equations, it's all part of the world around us, including the wild world of plants, in this case bamboo. Which brings me back to my original, just taking care of my bamboo plant, which I think is kind of neat. And then exactly what do you use this for? Ah, I just figured it out. You figured it out too, right? Of course, gardening, right? Gardening, you have to comb your hair, because when you're out gardening, you want to look very good. And by the way, if you're bending over a lot, you might have your back, so you can use this to kind of, ooh, ah, that's what it's for. Finally, a good use for garden tools. Have fun thinking about math, and I'll see you soon.
Thanks for watching, and I'll see you on the next one.